After studying this module, you shall be able to understand the Markovitch portfolio optimization theory. You would be able to elaborate the concept of an efficient portfolio. You would be able to construct an efficient frontier. You would also be able to understand the concept of utility theory and finally explain the process of portfolio selection. We can remind ourselves that the model of portfolio selection proposed by Harry Markovitch in 1950 marks the beginning of what is called the modern portfolio theory. This theory was introduced by him in a seminal paper called Portfolio Selections. It was published in the Journal of Finance in 1952. He was awarded the Nobel Prize in Economics in 1990 for the seminal contribution. His method of portfolio optimization is also often known as the Markovitch model, which is a conceptual framework for the risk-return choices. It is the mean variance criterion for selecting the optimum portfolio of an investor. It emphasizes the importance of diversification of investments to reduce the risk of a portfolio and also shows how to diversify such risk in an efficient manner. Let us now consider the concept of Markovitz's portfolio theory. The objective of each rational investor is to hold a portfolio so as to maximize the return and minimize the risk at the same time. It becomes important that he constructs a portfolio that benefits him with the highest gain with the lowest risk. Such a portfolio is known as an efficient portfolio. The set of efficient portfolios plotted on a graph is known as an efficient frontier. From this set of efficient portfolios, an optimal portfolio is to be selected for investment. Markovitz's portfolio optimization model is a method of selecting the optimum portfolio. The two fundamental attributes which form the basis of such selection and construction of an efficient portfolio are mean and variance. Considering the combination of mean and variance is the key to formation of an efficient portfolio. Now, let us consider the combination of mean and variance, and since we consider the combination of mean and variance, the Markovitch theory is also known as the mean variance criterion of Markovitch. The Markovitch approach of portfolio selection by a rational investor is guided by two important criteria. Investors are risk averse, that is, given two portfolios with the same expected return, they will prefer the one which has a lower risk. Investors are utility maximizers. Given two portfolios with the same level of risk, they prefer the one with the higher expected return. These two principles or two criteria are exact complements to each other. The Markowitz model involves three logical steps for creating an optimum portfolio: delineating the set of efficient portfolios, specifying the risk return indifference curves or the utility curves, and choosing the optimum portfolio. Now let us look at the assumptions of Markowitz theory. The modern portfolio theory of Markowitz is based on the following assumptions regarding investment behavior. Investors consider each investment alternative as being represented by a probability distribution of expected returns over some holding period. Investors maximize one period expected utility and their utility curve diminishing marginal utility of wealth. Investors estimate the risk of the portfolio on the basis of the variability of the expected return. Investors base decisions solely on expected return and risk, so their utility function of expected return and the variance or standard deviation of return. For a given risk level, investors prefer higher return to lower return, and similarly for a given level of expected return, investors prefer lesser risk to more risk. Under these assumptions, a single asset or collection of assets is measured to be efficient if no other asset or collection of assets offers developed expected return for the same or lower risk with the same or higher return. Now let us consider a feasible set of portfolios. Feasible set of portfolios means the set of all possible portfolios in which the investor can possibly invest. That could be created by combining a given number of securities in different proportions. It also is called a portfolio opportunity set, comprising of portfolios in the opportunity set has an expected return and standard deviation related with it. The opportunity set includes both efficient and inefficient portfolios. The inefficient portfolios are those dominated by other portfolios. The investor would be interested only in efficient portfolios. The opportunity set or feasibility set can be depicted with the help of a graph. Figure, we have depicted a risk return relationship in the form of a graph showing feasible sets of portfolios. Expected return is measured on the y-axis and the standard deviation is measured on the x-axis. Each possible portfolio can be represented as a single point on the risk return space with the help of expected return and standard deviation associated with it. The shaded area in the graph depicts the sets of all possible portfolios that are constructed from a given set of securities. The opportunity set forms a shape as the portfolio in the set consists of securities that are not perfectly correlated to each other. Now, let us examine the graph in terms of various points. Point B is at the highest point and is exactly on the vertical axis. So is point A, which is also on the vertical axis but is much lower down and in a sense is on the negative portion of the vertical axis. The true extremes are F and its complement on the left hand side. F is in the positive quadrant and then we have certain other points C and D which are at the outer margin of the shaded grey area but are well below. A, for instance, is a point which is not lying on the outer margin or the exterior, or you could say on the boundary of the set. So, on the boundary there are 4 points B, C, D and F. These are all efficient portfolios, but a point A which lies within is not an efficient portfolio. Now let us consider more about efficient portfolios. An efficient portfolio is a portfolio that deals with maximum return for a given level of risk or offers minimum risk for a given level of return. It is because of the dominance principle, the efficient portfolios dominate all other efficient portfolios for a given level of risk and return. For a better understanding of the concept, let us consider portfolios A and B. Both A and B have the same risk level, but portfolio B offers higher return than portfolio A. Therefore, portfolio B would be preferred to portfolio A. Now compare both E and F. Both offer the same expected return, but E is less risky than F. Thus, E is efficient to F. Again, compare both portfolios C and A. C would be preferred as a portfolio as A and C offer less risk for the same expected return. Now consider portfolios E and C. Portfolio E would be preferred to C as it offers higher return for the same risk. Therefore, now portfolio B represents the portfolio with the highest expected return and portfolio C represents the minimum variance portfolio amongst all the portfolios in the opportunity set. Hence, we find that the efficient portfolios lie on the northwest boundary of the shaded area. Further, now efficient portfolios offer the best return for a given level of risk. A line joining all the efficient portfolios plotted on a risk return graph is called an efficient frontier. The northwest boundary of the shaded area depicting the feasible portfolios is an efficient portfolio for the given opportunity set. The efficient frontier is shown separately in figure. In this figure, you can note that on the y-axis we have the expected return and on the x-axis as usual we have the standard deviation. Now the curve CB, which is upward sloping and is convex to the x-axis, is representing an efficient frontier. X and y measure respectively the standard deviation and the expected return, where CB represents the efficient frontier, where C is the minimum variance portfolio and B is the maximum return portfolio. The portfolios lie on the same efficient frontier represents the set of efficient portfolios which investors would prefer to hold. Thus, the efficient frontier is a concave curve from the risk return space. However, earlier we had defined it with respect to the x axis, and the y axis it is convex, and it extends from the minimum variance to the maximum return portfolio. The selection of the optimal portfolio is done in the following manner. Once the efficient portfolios are delineated, the next task is to determine the optimal portfolio for the investor. The selection of the optimal portfolio on the efficient frontier by the investor will depend on the risk return trade off, the degree of risk aversion to the investor. A high risk averse investor would hold a portfolio on a lower segment of the efficient portfolio, whereas a risk seeking investor would hold a portfolio on the upper segment of the efficient frontier. Now let us look at risk return utility or indifference curve. The risk return trade-off function of an investor can be reflected through a series of risk return utility curves or indifference curves. The indifference curve is an upward sloping curve moving from the left to the right. The slope is so because of diminishing marginal utility or preference of the investors. The indifference curve displays all arrangements of portfolios that are similarly desirable to a specific investor. The indifference map, as shown in figure, is a family of indifference curves. We have IC1, IC2 and IC3. On the y-axis we have expected return, and on the x-axis as usual we have the standard deviation. This is a utility map or an indifference curve map. And then we notice that there could be 2 points on each of these curves, such as P and Q on IC1 and A and B on IC2. These are equally preferred, whereas it would depend upon the nature of the investor. We see that all the three, IC1, IC2 and IC3, are risk return indifference curves of investors, and each point on the indifference curve gives the same level of satisfaction. At point P and Q, which lie on IC1, provide the same level of satisfaction to an investor. Similarly, points A and B on IC2 also provide the same level of satisfaction. Also, each successive indifference curve moving upwards from right to left give a higher level of satisfaction. Therefore, IC2 is higher than IC1 and IC3 is higher than IC2, and so on, and the level of satisfaction keeps on going up. The optimal portfolio selection, given an efficient frontier and a risk return utility curve plotted on a graph, we find the optimal portfolio of a point where the indifference curve is tangent to the efficient frontier, and this is the point of maximum utility for an investor, which determines the optimal portfolio of investment. This is shown in figure, and here as usual we have expected return on the y-axis and standard deviation on the x-axis. The optimal portfolio, as you could notice, amongst all these indifference curves, the entire indifference map IC1, IC2, IC3 and so on, there is only one point O prime at which the efficient frontier is exactly tangential to IC2. There is a unique point represented by O prime, which is the optimal portfolio. Now let us summarize. The portfolio theory, also known as the modern portfolio theory, was first developed by Harry Markowitz. The theory suggests a process of optimal portfolio selection from a feasible set of portfolios. The theory is representing the effort to maximize return for a given level of risk or minimize risk for a given expected return. The theory assumes that investors are rational and they want to maximize their utility function and to minimize their risk. Since the theory is based on mean and variance, it is also known as the mean variance criterion of Markovitch. An efficient portfolio offers greater return for a given risk or minimum risk for a given return. Efficient frontier is the line joining the efficient portfolios on a risk return space. The efficient frontier has a concave shape and prolongs from the minimum variance portfolio to the maximum return portfolio. Selection of the optimal portfolio by an investor depends upon the degree of risk tolerance or risk aversion by an investor. The risk return trade-off of an investor is reflected through the indifference curve or utility curve. An optimal portfolio is a single point which is a point of tangency between the efficient frontier and the investor's risk utility curve, one amongst the entire map. One indifference curve will be the chosen one, and amongst on that one single indifference curve there would be just one point at which the efficient frontier is exactly tangential to the indifference curve.